thanks for being here of 12 talks, and you're coming here to a presentation about continuous integration, continuous delivery with containers, which is going to be super dense. I have a lot of content here. Reason I'm talking in English today is because I know that there are some people in the audience that don't speak Spanish. And I live in Germany. I can tell you that going to an event and not being able to attend talks is kind of sucks. Just for me to understand where everyone is, how many of you have experience with containers? How many of you okay, that's nice. Keep it up. How many of you know what Kubernetes is and have some experience with Kubernetes? Okay, cool, thank you. So I am Nacho Coloma. I am organizer of CODEMOTION Spain, but I'm also a customer engineer at Google. That means that we help companies to deploy their systems in the cloud. In my case, I'm particularly specialized in container workloads and Kubernetes and so on. But in general, I can talk about anything related to Google Cloud. Today, our talk is going to be mostly about two different topics. We're going to be talking about how to build your images using a continuous integration pipeline, which options do you have, and what are all the different concepts, and then how do you do that with Kubernetes and containers, specifically. Some definitions to make sure that we are all talking in the same language. Continuous integration means that whatever you are putting on Git is going to be automatically tested. That's continuous integration. Continuous delivery means that you're also going to build your artifact, your image, your jar file, your whatever. You're going to build your artifact, but you're not going to deploy it automatically. There is going to be some manual step at some point. Someone has to give the okay. Continuous deployment means that there is no manual process at all. It goes to master, or whatever tag you're using or whatever branch you're using, that goes to production if all the tests pass. The difference between continuous delivery and continuous deployment is business policy. If you work in a highly regulated environment, you're a bank or you're an insurance company, you need a manual okay in order to send this code to production, because this is how the business works. If you can choose, then go with continuous deployment, if you are going to choose between these two. Otherwise, continuous integration is also totally fine. But if you're going to choose between delivery and deployment, go with deployment if you have the option. An example of what we're talking here, and icons are just for illustration purposes. So this is not endorsement of anything, but basically you have a Git repository, your code goes to the Git repository. This is going to automatically launch your continuous integration pipeline, Jenkins, GitLab, whatever you're using, and then this is going to test, build, and then publish your artifact somewhere. An artifact can be, if you're working with Java, this is a jar or WAR file. You have a Python, you're working with Python, that's a Python archive. Node.js, different thing. Whatever you consider is your artifact is going to be put somewhere. This is the application that I'm building, this is where I'm putting it. We're not talking about images, we're not talking about containers yet. While doing this, continuous integration means whatever you want to think that continuous integration is. You can be thinking about Jenkins on-prem in your own data center, Jenkins in the cloud. You can be thinking about GitLab or whatever. That would be IaaS, that would be infrastructure as a service. You assume the responsibility of everything in your continuous integration pipeline. There are also options like platform as a service, and I'm thinking here Travis CI, Circle CI, and so on. These are going to be offered to you as a service, and you just connect that with your code and start working with that. Everything that we're going to be talking about here can work with both approaches. So we're going to be flexible here in general, but you're going to see me talking sometimes a lot about Google products, also because this is the ones that I know better, but we're going to be talking about a lot of open source as well. Next step, okay, same diagram, same thing. Code goes to Git, and then from Git, we are going to trigger something in our continuous integration environment, and now we're going to be publishing our artifact and also deploying this. Deploying can mean deploy to QA, to test environment, can be deploying to production. And it's on you. Like, for example, hey, whatever is being committed on this branch is going to go to production. This other branch is going to go to my QA environment. Or this kind of tag. If you're tagging it production release 3.4, whatever starts with production release is going to go to production. It's your decision if you're going to work with different branches or you're going to be working with different tags. What's the next step? If you're just building your jar file and then you're deploying that jar file automatically, This is okay for the older days, but these days, if you can build an image, it's better because that way you can auto-scale faster. Auto-scale meaning when you're starting a new machine, that machine can start faster if everything is already compiled in a virtual, in a virtual disk. It's already prepared, like, okay, with this disk, I'm going to get started, and I am already up and running. Instead of building a jar file that now my environments have to copy, and then the environment I cannot delete it, or maybe yes or no. If you want to auto-scale in the cloud, build an image that you can auto-scale with. We're not yet talking about containers. It can be containers, but it can be just a virtual machine. And here we can be talking about using tools like Packer, or in the case of Google Cloud, there is G-Cloud, which is super easy to use, but Packer is independent of the platform, which is also cool. You can work with Google Cloud or build a virtual machine image for AWS. And then you have container images, and for many people, container means Docker, but that's not necessarily the case. You also have Windows containers, Rocket containers. You can choose. The vast majority is using Docker, but still. We're not going to talk about virtual machine images best practices. We're just going to focus on containers. If you're interested in this, and this is just a note for the future, there is a great article called Image Management Best Practices about, hey, how do I deprecate my images? How do I share my images between projects? How do I build these for the future? How do I delete or when can I delete images and so on? How do I keep them up to date, etc.? And today we're going to be talking about containers, and specifically containers with Kubernetes. Kubernetes is a container orchestrator. When you're working with Docker, everything that runs inside of your container is clear. You have a Docker file, your Docker file specifies everything that runs inside of the container. Kubernetes is going to take care of everything else. How many copies do I need of this container? Which load balancer am I going to have in front of it? Am I going to be sending traffic? Can I auto-scale my containers? Kubernetes does all of that. It's based on 15 years of best practices at Google working with containers. At Google, we work with Borg, which is our specific technology, developed in-house at Google, but the problem with Borg is that Borg works for our data centers. And it's not applicable for the rest of the world. For some people, they need more flexibility than we need internally at Google. So we know where our log files are. We know exactly how our data centers are located. Borg is not flexible that way, but Kubernetes is. Kubernetes is basically the re-implementation of everything that we have seen in Borg done today in Go and implemented open source from the scratch. You can deploy Kubernetes anywhere, on AWS, on Azure, on Google Cloud, on your own laptop. So if I'm adding Kubernetes to the same diagram that we were working with before, so code goes to GitHub repository, to Git repository. Your continuous integration pipeline is going to be triggered, and I'm going to publish an image somewhere. I'm going to build a Docker image, and I am going to put it somewhere. Once done, the rest is just kube control deploy. One thing about integrating Kubernetes with continuous integration environments, it's just a command line tool. You don't need fancy plugins, you don't need anything special, you don't need to change the configuration of anything. Kube control is just a command line tool. And everything that you can do with kube control, you basically need authentication when it's done, and that's tricky. Once it's done, then it's just command line. In this particular example, what you can see here is the integration with Container Builder and Container Registry. Container Builder is basically a tool that can be used in Google, at Google Cloud, to build Docker containers without having to install Docker. And installing Docker is not always straightforward because incompatibility of libraries, because some packages are outdated or not. And with Container Builder, it's basically, hey, send this folder to Container Builder, tell me when the container has been built, done. Publish automatically wherever I want to publish. One of the good points of Container Builder, it scales automatically on Google side. And if you're thinking, hey, my continuous integration environment is going to be triggered 40 times per day, then maybe you have to start talking about, how are you going to auto-scale your continuous integration environment? But if you are not building the container itself, but you're sending it here, then auto-scaling is much easier. Because building your container can take time, minutes to hours, depending on where you are. And if that's outside of your infrastructure, then your environment can scale better. How about container registry? This is a Docker container registry service that you can have with Google Cloud. It's working out of the box. You don't have to do anything. You can just start publishing your Docker images. This is just an option. And if you're thinking, I'm going to publish my images on Docker Hub, perfectly fine. Yeah, everything that you can see here is replaceable by something else. You don't have to use a container builder. You can just use Docker in the command line. You have to configure Docker, but you can just use that in the command line. You don't want to configure to work with container registry. Everything can run with whatever container registry you want to use. Okay, so we have this Git repository, we're testing, we're building, we're publishing, and we have your image somewhere. What happens with the different, the different environments? We have test, QA, production. Am I going to generate a different artifact? So it works like this. If you only have an engineering team, if you only have developers in your team, and then one morning you need, okay, I'm going to connect to my database, and my database needs a username and a password. Then you're going to have a properties file with the username and the password. Then you have a test environment. Okay, now I need 4 entries, right? Username and password for production and also for test. Or maybe 2 different properties files. What happens when I need an SSL certificate? Oh yeah, wait, I know what's going to happen. That properties file or that YAML file or that JSON file is going to keep growing and growing. This is not what we call at Google operable. And operable means separating development and DevOps, separating what the team that has to manage the environment and what the team that is developing the application are doing. Part of 12-factor is generating a single artifact, in this case, a single Docker image, and then using parameters to say, okay, this image is going to receive the username and password for the database as environment variables, as files in the file system, whatever. And then the DevOps team have to configure that. So the development team, the engineering team, is going to be developing, okay, this is my container, and in the documentation of my container, these are the variables that I'm expecting. The DevOps team have to configure that in the cluster. And that's basically separating roles. And in this case, injecting, in the case of Kubernetes, that's injecting either as config map or as secrets, your choice. We were talking about 12-factor. 12-factor is in general a list of best practices, and many of them sound like just common sense. But in general, creating immutable artifacts, a single artifact that works for all your environments, being able to scale horizontally, that's one of the best things of containers in general and Kubernetes in particular. Having a single system of monitoring and metrics, and it may depend on your cloud provider or your specifics, and being operable, which is what we just talked about. Like the configuration is injected to the cluster, not with my source code. Microservices, it depends on who you're talking to. And even at Google, when you're talking to different people that are all working with containers, you're going to hear 2 different stories. Like microservices is not a requirement for cloud native applications, or microservices are a requirement for cloud native. I am of the opinion that they are not required. Like, you have an application that is living on-prem and is not cloud native, and you're going to make it cloud native. You make it 12-factor, auto-scaling, and so on. Microservices can come later. You can just say, okay, this is a huge monolith that I'm just going to put online. If it's auto-scalable, and if you can start containers at any point in time, then you're fine. Then you can, microservices can be added later in a progressive way or slowly over time. These days, so there are 3 different kinds of tools for doing things in the cloud. We have configuration management tools like Chef or Puppet or Ansible or Salt. Building your configuration and specifying how your configuration should be. You have cloud provisioning tools, some of them specific to Google Cloud, like Deployment Manager, or others, like Cloud Deployment Manager, exactly, or CloudFormation in the case of AWS. But there are also some of them that are independent of the provider, like Terraform. And if you're thinking about containers, anything that is not in a container comes here, in Terraform, in general, in the cloud provisioning tools. Like, hey, I have a messaging bus topic. And with AWS, it's one tool. With Google Cloud, it's a different tool. And this is going to go in Terraform. Or I need a managed SQL server. So that can go in this kind of frameworks as well. And then everything that is inside of containers. It can be Kubernetes that we're talking about here, or it can be Mesos or Swarm or whatever tool you're thinking about. These days, we're finding out that more people are here managing things inside of containers than anywhere else. More here than in cloud provisioning, and more in cloud provisioning than in configuration management. People are spending more time in these tools because they are easier to manage huge workloads. And we can talk about that any other day. So when you're deploying, your source code is one thing, your deployment code is a different thing. And in general, and I don't know how many of you are familiar with this expression, cluster deployment as code, configuration as code. And basically, it speaks about how the configuration of your servers should be also belong in your Git repository. Wherever you're putting all your Python code, Java code, JSON code, maybe in a different repository, maybe in the same repository, it's up to you. But the configuration, and in this case, the YAML files for Kubernetes belong in Git. It's not something that just belongs in some laptop or you're just creating in the command line. And I have seen this from people that are starting with Kubernetes. With Kubernetes, you have two options. You can create configuration using YAML files, or you can create configurations using the command line. If you're creating the configuration with the command line, it's not going to be on Git. So people mostly, most people that are working for long-term deployments, they are working with YAML files because then they can be committed somewhere. Since we're on topic of best practices in general, taking out time, what happens with shared clusters? For how many of you production is shared with either QA or test in terms of the same machines? Nobody here. Okay, couple. Okay, so not ideal. Not ideal. So it happens like this, and this is from Kelsey Hightower. When we do that, it's okay, and sometimes it's necessary because there are cases where this is the way it is, but then we don't have QA, we only have production. Meaning that, let's say, for example, on Kubernetes, you have a single cluster, and then you can separate workloads by namespace. You can say, okay, I have a production namespace, and I have a QA namespace. They cannot see each other, which is true. But what happens if I am upgrading Kubernetes and I am breaking the cluster? The whole cluster is down because I am upgrading Kubernetes and I screwed up. I screwed up in production because I don't have a QA environment. What happens if someone is deploying a workload and they didn't control the amount of memory of this particular pod? And suddenly they are killing nodes in the cluster because they are eating all the memory, all the possible memory. And screw-ups happen. This is what QA is for. So sometimes it's necessary, and I have spoken with customers that it's like, okay, it makes sense for this particular case. But in general, try to separate QA and production if possible, because otherwise there are ways open to break your production environment. You can still use namespaces to differentiate teams. You can still use namespaces because namespaces are awesome. And think about that. I have a team of 20 people, and then I'm going to start assigning namespaces to groups of 5 or following the 2-pizza rule or whatever you want to do. And the reason is because then I can specify the maximum amount of memory and CPU and role-based access. I can specify that per team, which is awesome, actually. So using namespaces makes sense. But to organize teams and to organize features instead of separating different environments. Enable direct access for dev, disable for production, meaning in production, the only one that should be able to deploy something is your continuous integration platform. Jenkins, GitLab, Travis, whatever you're using. That's the only one that should be able to deploy to production. In dev, all your devs should be able to deploy. Everyone should have access to kube control and be able to play in development and maybe QA, who knows, up to you. In production, then no. Anything that is going to production should have a way of deploying through, okay, code goes to Git, Git goes to Jenkins, Jenkins goes to production. In dev or QA, whatever you want to do. I mean, experimentation is good, and this is how we are more agile. And then specifying resource requests and limits. This is just a best practice of, hey, always specify a maximum amount of CPU and memory. You can also specify a default maximum amount of memory and CPU for a namespace, or a total maximum amount of memory and CPU for a namespace inside of Kubernetes. So I'm going to do 2 demos today, and one of them is about, okay, let's create a Jenkins environment. This is going to be super dense in amount of information, so I'm going to try to play it slow and point you to the relevant bits. You're not going to follow all of it because there is going to be a huge amount of code in the screen. So I'm going to try to play nice. Stop me if I'm going too fast, okay? So okay, better. So I'm going to do something. So Helm is a tool that comes quite close to Kubernetes. It's a kind of template tool where configurations come already prepared for, hey, I want to deploy MySQL. So you go to Helm and you say, okay, Helm, can you give me a MySQL? Can you give me a list of MySQL configurations for Kubernetes? Yeah, you have these. Hey, I'm interested in Helm. Can you give me a configuration for Postgres? Yeah, I have this here. So do I have something for Jenkins? Yeah, here. If I want, I can use Helm to create right now a working Jenkins instance. By default, it just works. I want to configure a little bit of it. So let's see what we got here. So Helm, come on. Spec there. So by default, all the charts inside of Helm, charts are the configurations that come inside of Helm. All the charts come already with a configuration, which can be what's the word? Changed by you. So in this case, you can see here everything that is available, and some of them are, for example, hey, this is the name that you're going to have by default. This is the image pool policy that you have by default. And then you can override some of these values. You can create your own YAML file and say, hey, I want to change the minimum and maximum amount of memory of Jenkins. I want to change this value. I want to use something else. So you can play with this configuration. And I have my set of values that I'm going to use to create my configuration. So Helm. So these are my values. Sorry, let me do this again. There, better. So I'm going to use Helm install my values and stable Jenkins. Now, this is going to create a deployment. This is going to create a service. In terms of Kubernetes, this is the load balancer and the containers that are going to live in my cluster. So let me show you what we have right now. Give control, get pods. So this is the pod that is right now getting started. It's right now starting, so let's give it some time. Basically, when a node still hasn't downloaded an image, it can take some time to get the image downloaded and get it started. When the image is already locally in the node, it's always much faster. Control get services. These are the load balancers that we have, and I am particularly interested in this particular load balancer. This is where my Jenkins instance is going to live. My external IP is being assigned, and it's going to get some time to get assigned. So I would like to show you what are we going to go with Jenkins when Jenkins is up and running. Okay, so I'm going to do something. I'm going to leave here this watch. Watch is a command in Linux that is going to repeat whatever comes after this every 2 seconds. Watch, control get. I'm going to go with services. Okay. Oh yeah. Okay. I have already an external IP address. Let me show you what I want to work with. So this is a super simple. Oh, sorry. Bigger, right? There. This is a super simple Node.js application. What you can see on the screen is a Docker file that basically says, okay, I'm going to extend a Node.js, a Node Docker image. I'm going to use my package.json, and then I'm going to install my dependencies, run some tests, and that's it. My application is called app.js. Sorry, not testing here, just install the dependencies, and this is my application, app.js. So this is the simplest thing that I could do with a Docker file. This is the image that I want to build. So let me see if my server is already up and running. Okay, I have a Jenkins. Do you remember the last time that it took you less than 1 day to install Jenkins? Because I do, actually. Okay, so when you are installing this with Helm, Helm is telling you, okay, run this line to get the password to connect to Jenkins. So this is exactly what I'm doing. I have already a script for that, because I'm terrible at remembering things. So here we go. Come in. Oh, and by the way, this is a really slow cluster because, oh, I didn't mention this. So this talk, I have given it in London, Berlin. I'm going to deliver that in Munich and here in Madrid once. And I came like, hey, I'm going to wrap this talk. I'm not going to do it next year, probably sometime, but I don't have plans to repeat this talk. And I wanted to wrap it up like, here is a good place to do that in family and so on. Yeah, and then when I was coming here, hey, I don't have access to any of the systems that they have at Google because I didn't bring my corporate laptop with me. So last night I was just repeating this from scratch. Yeah, I ended up at 2 in the morning. Typical story about talks. So I have here Jenkins. So let's create a job. This is going to be a Jenkins pipeline that I'm going to create. So I want to create here one for my Node application. And I'm going to create a multi-branch pipeline, meaning that when someone is committing something on any branch, it's going to trigger my pipeline that I'm going to create here in Jenkins. So, okay. You're on it, right? Okay, perfect. So I'm going to add a source. This is going to be a Git repository. I'm going to play it simple. I'm going to go with this particular Git repository here. Yeah. So perfect, save. Oh, yeah, okay. So the first time that you're creating a pipeline on Jenkins, it's going to automatically run the pipeline. I'm going to open the logs of that. And this is going to take some time, so I wanted to show you what are we running here. I just connected with a Git repository, and Jenkins is already doing stuff. The modern versions of Jenkins are going to automatically detect a file that is called Jenkins file, which is similar to the Travis file of Travis CI. It's a file that describes your pipeline. In this particular case, what we're running here is this. This is my Jenkins file. This is Groovy code. That is basically what I want to run in my pipeline. I am doing 3 things. First of all, I am defining my environment variables. Which project am I working with? What is the URL for the Docker image that I want to build? And in this case, I am building an image based on my build number. Anytime that you're configuring a continuous integration environment, you have 2 options. You can go with a number that is increasing automatically, and that works. Hey, whatever happens on master, automatically increase the number and create a new build. That works. Or you can go with tagging. Hey, when I tag and the tag is release something, then launch everything. So your call. In this case, so I have these 3 variables. I'm going to run all the Node.js things. I'm going to test my stuff. This is the test phase where I'm just running npm test my things. And then I'm going to build my Docker image. I'm building my Docker image. In my case, I have tried 4 different options. And by far, the easiest for me, but your case may be different. For me, the easiest case was, okay, send something to Container Builder, which is this line that you can see here. Submit my current folder, send that to Container Builder, build it there. And the reason is because I was trying to run Docker here in 3 different ways, and it was a pain in the ass for a demo. If you have all the flexibility of doing things by hand, then it's a different thing. Deployment time. No, so yeah, I have configured everything. I have built my image. I have uploaded my image. I have uploaded my image. I want to deploy my image. This is on Google Cloud. This is the line that configures Kubernetes. Once you do get credentials, kubectl is automatically connected to your cluster, and now you can start doing things. In my case, I'm going to get my deployment descriptor, my YAML file for Kubernetes, and I'm going to update. And this line is horrible. I'm basically changing the version number from 1.0.0 to whatever release number I have. This step is always ugly. And then kubectl apply. Hey, update my deployment. What I have done, I have taken my YAML file, I have increased the version number, and I'm deploying it again. And that's it. So this line is just me that I want to be fancy, and hey, show me the HTTP that I have to open, and so on. But this is just me being fancy. If I want to do a different thing depending on which branch I'm in, you can just add your own code. Hey, if this is my branch, or this is my tag, or this is whatever, you can just do that. And if you want to receive an email if something is failing, then you can just do that as well. Hey, send me an image if something is failing or whatever. So let's see if that was enough talking for this to finish. Actually, it was. So what we have seen here is npm running everything, installing all the different dependencies, and in the end, and in the end, what I have here is a URL that I can just open, and if everything went correctly, I have here my demo application, which is a super stupid, just read-only application. So what we have done so far, we have created a Jenkins environment. We have created a Jenkins pipeline. We have connected two different environments, our continuous integration environment with a simple Node application, and we have deployed that. Things for you to know. With Jenkins, you have two options. You can run Jenkins inside of containers, or you can run Jenkins to build containers. We're doing both. We're running Jenkins inside of containers, and we're running Jenkins to build containers. You can choose to do one or the other. You can install Jenkins manually in some kind of machine, and then having Jenkins creating your containers and doing all these beautiful things, or having both. It's your call. Do you want to see how the configuration looks like? Oh, give me a second. So if you want to check, okay, is this actually running as expected? With kubectl, you can just run a command. In this case, this particular command, the cat bar jenkins config.xml is to review a little bit, okay, which kind of configuration do I have in Jenkins? Have it generated here. And you can see here everything that has been generated in Jenkins. Particularly interesting for me is the injection here of my secret. This is, remember before when we were talking about your configuration should be injected into your containers? This is my username and password for Google Cloud. This is how I am injecting it. You can inject secrets either as files or as environment variables. I am injecting them as files here. If you can choose, go with files, because files have better security than environment variables, and because files can change the contents in real time and you don't have to reboot anything. You read the file, it has value A, change the configuration, read the file, it has value B, you don't have to reboot anything. And also security with files is in general better. You can assign permissions to files, you cannot assign permissions to environment variables. So this is how I injected my secrets to connect to Google Cloud and so on. So this is the first demo that I wanted to do here today, which is basically using Helm to create a Jenkins environment, configuring my Jenkins pipeline, and compiling my container, and then deploying. There are other ways of doing things, and if we're thinking about platform as a service, okay, I don't want to manage Jenkins, I just want continuous integration to happen, that's where you can use Container Builder. We have used Container Builder here today just as a command line tool, which is a possible case, like gcloud container build something something, and that's going to automatically compile your Docker image. With Container Builder as a continuous integration tool, whatever happens in your source code repository is going to automatically trigger your pipeline. There are different ways, but in general, the screen looks exactly like this. Like, hey, I want to create a trigger, and this trigger is going to have either a branch, it's going to be triggered by any commit on my branch, or it's going to be triggered by a tag. Any commit on my branch typically means a merge, not individual commits. So you don't create this and say, okay, whatever happens in master, and then everyone is committing to master. It doesn't work that way. But you say whatever happens on master, and then people are working on their own individual branches. When they merge into master, this is going to be triggered. So these are the typical two options. And then you have two ways of compiling your container. The simplest possible way would be, okay, let me use a Docker file, which is fine for simple applications. But if you have something more complex, you can just use cloudbuild.yml. Cloudbuild.yml is a script where you can say, I have different stages. I want to run first this, then this, then this, and in the end, I'm going to have my container image ready. In this example over here, I'm going to start using this particular container image, Ubuntu, the default Ubuntu one, and I want to run this particular script where in this script I'm going to be doing crazy things. And in the end, in the actual folder, I'm going to have files. I'm going to be compiling my Go application. I'm going to be compiling my Java application. I'm going to be installing my Node.js dependencies. I'm going to do crazy stuff. Once I'm done, in the folder there is going to be some content. And after that, the next step is going to take place. And the next step is going to be using a different Docker image, and in this case, it's going to be a Docker one, to build my Docker container image. I can do different steps to just run different things with different environments. Maybe I need the Go compiler for the first step, but then I don't need Go compiler anymore, so I don't need all these dependencies. So this is multi-stage building for those that are familiar with that on Docker. So basically, you have a Git repository trigger, and then your configuration can be specified with either a Docker file or cloudbuild.yml, and this is going to be automatically uploaded to container registry. So let me show you what that looks like. So, because I'm a lazy guy, and I didn't want to do everything from scratch. So I already created a build trigger before coming, but it's basically quite straightforward. Oh, sorry. Better. There. So this is my trigger, and as I was mentioning before, two options. In this case, in the previous case, we were working by branch. Anything that is committed to the branch is going to be automatically generating a number. Here, we're going to use the tag number. The tag is going to have a regex, which in this case, anything works. And I'm going to use cloudbuild.yml, which exists in my repository. So this build trigger, I can launch right now. If I'm going to launch it manually, I can just tag something on my repository. But in this case, I'm going to run this on version 1.0, which is a tag that already exists. Here in build history, I can see my script already running. I would like to show you now what are we running here. But let me see first that everything seems to be running mostly fine. These are the 4 steps of my cloudbuild.yml, which has 4 different steps. And then these are the logs, and everything seems to be working fine. What am I running here? This is the contents of cloudbuild.yml. Same case as the Jenkins file. This file is inside of the same Git repository. I have all my code, I have my Jenkins file, I have my cloudbuild.yml. Typically, you're going to choose one or the other. I am using both. In this case, here I'm going to be building my Docker image. After building the Docker image, I'm going to, so this is basically Docker build, what I'm running here. After running Docker build, I'm going to run npm test, which basically means that I'm going to test everything. First step, create my Docker image. Second step, test everything inside of my Docker image. If everything is fine, I can continue, right? Then I can publish. And this is where I want to push my image. I am pushing my image to container registry. One of the good things is that it comes configured out of the box. I don't have to do anything to have this line up and running. And the next is, hey, deploy on Kubernetes. This is the same thing that we have done with Jenkins. I am getting credentials again. I am configuring kubectl here. And then replacing the line. Remember that line that was ugly? This is the same line again. I am changing the line of my version. Before, it used to be I'm using a correlative version number, and here it's the tag name that I'm going to be using. So what I'm doing here, I am building an image, and this image that I'm going to be deploying, I am updating in my YAML file for Kubernetes. Once it's done, it's kubectl apply and apply my configuration on Kubernetes and done. Let me see where we are. Actually, where are we? This is my load balancer. This is no here. So everything has been running. Funny thing, my cluster is super cheap because I was configuring this yesterday. So I'm only using machines with one CPU and not a lot of memory, meaning that my Jenkins cluster is quite slow. And I mean that because yesterday night it was quite slow. But this is automatically scaling on Google, meaning that this particular build approach is like 4 times faster than what I have in my cluster. And the reason is because I don't want to pay for an expensive cluster right now. Because it's on me, so. So then everything was working fine. All the node dependencies have been installed, the node tests have been run, and then it's been deploying here. If it's running, then I should be able to connect to this IP address, and I should be able to see the same application that we saw before, which is here up and running. What do we have in this particular cluster? So what this application has deployed is my load balancer, my application. This is part of my Kubernetes configuration. So we have a Jenkins configuration that we have run with Jenkins, running on branches, and we have right now a container builder configuration that is running on tags. One last thing. So this is the list of images that we have. So this is my application. And what you can see here is all the different versions of this application that have been uploaded. What we have just run is this application that you can see here, version 1.0 of this particular container. This is what you can see inside of Container Registry. So we have been working with Container Registry, we have been working with Container Builder to build the same thing that we had before with Jenkins, but we didn't have to configure much here. Some permissions, yes, but not a lot. Yep. For those familiar with all the latest and greatest in Docker, cloud-build.yaml is basically the same thing that you can have with multi-stage containers with Docker, meaning that it's now part of the standard that you can specify, okay, I'm going to build Docker with a first step, I'm going to do a set of things, and with a different image, I'm going to do a second set of things. Think, for example, hey, I want to build a Go application, I need a Go compiler. But if I just go with my image that includes the Go compiler, then I'm going to end with something that is bigger than I need because Go doesn't need anything. Go is going to be a statically linked application. So you can just say, I'm going to have 2 different steps. The first one is going to go with the Go Docker image, which is a big one. And the second one is going to leave me with a much smaller, much leaner container. So that's the idea of multi-stage Docker containers, and in general, cloud-build.yaml, which you can use to do the same thing. So wrap up. You can build images in your container integration pipeline. It's your option to say, I want to use containers or I don't. In general, they help you to auto-scale faster. If you're using containers on Google Cloud, a container is going to start up in less than 3 seconds in the 99th percentile. And if you're working with virtual machine images, it's going to take you more than 30 seconds or 40. So that's typically how it works. But in general, an image, a compiled image of any kind, is going to be faster than, okay, start the machine, now copy something from this place, copy into my server, get this started, and for auto-scaling, which is what you want to do in the cloud, for auto-scaling, starting up is important. It doesn't matter what do you want to use for continuous integration. It can be that you want to go with GitLab, which is an awesome tool, Jenkins, which has a lot of different kinds of documentation, so sometimes it's good, sometimes it's not. You can go with whatever framework you want, and Travis CI is also a really great environment. You have seen Container Builder here. You can just use whatever you want. And in general, you can build your releases based on either a branch or a tag, and again, your choice. So both are perfectly valid. And I think that I'm wrapping up in record time. So all of this code is available online. So you can just check it out later, and with some proper time, okay, like read properly and follow the code and say, okay, I want to reproduce this on my environment and so on. Happy to take some questions here because this is basically it today. Thank you. Any questions? Yep.
So yeah,
Hey.
congratulations on your talk. I think it was awesome. It was a walkthrough through the entire pipeline you can use to build containers and deploy them. But I'm using some similar approach with GitLab actually. But the thing I wanted to ask, I don't have any idea about Google Cloud provider. But you guys have like some tools for static analysis of the containers, like layer or vulnerability analysis of the containers after you build them?
On the record, no. There are going to be some announcements next year, but I'm going to leave it there. So, sorry about that. Let's talk later if you have specifics that you would like to discuss, but yeah. So, not today.
Or container signing?
Container signing.
Like notary or...
Yeah. Container signing, I don't think we're working on that, right? So I just don't know. So let's go that way. I just don't know on container signing specifically. Products like Claire is a different story, but container signing, I don't know. I would have to check that one out.
Some customers will do deployments on containers and they require some specific signing policies.
Yeah. No, I understand what you mean. I understand the process of what you mean, but I don't know exactly where we are on that. I can get back to you on that. Actually, because I actually should know. So let's talk later. Okay. Any other question? Which is actually about the start, right? Because 2 questions and I couldn't answer either. So sorry about that.
Do you upload the...
Sorry?
Just like do you upload?
I will put them in the agenda. They will be in the agenda like, I don't know, tomorrow maybe. So I will share the slides as well. Yeah. By the way, for those interested, what you can see here on the slide is my Twitter, and every now and then, I am not like too verbose, but every now and then I'm talking about this kind of stuff. Any other question? Oh, yeah.
Is there any reason to be using that ugly command to replace the image instead of use kubectl set image?
Actually, that was the other option. So you have seen that ugly image. I'm going to have a YAML file and I'm going to change the version name. And the reason why that line is there is because when I was actually writing that demo, I was super focused on there must be a YAML file. In this particular case, if everything that you're changing is just the version number, using the command line is perfectly fine. So you have a command line in Kubernetes that is going to say, in this particular deployment that is already created, up and running, change this line. The thing is, your continuous integration deployment then cannot create your deployment the first time. The first time you have to do that manually. And after that, everything can be automated. But your first deployment, you need a YAML file. So you have to do that deployment manually and then just change it with one command line in your pipeline. So yeah, that works. Actually, that was, if you want to score one point, that's exactly the point that the team in Delivery Hero was making when we were talking about this. Yeah, that's true. More questions? Yep.
Yeah, it's about your Jenkins file. I've seen you define your whole pipeline in that Jenkins file.
Mm-hmm.
For some bigger pipelines, you could actually upload it to GitHub or something. Have you defined it like that just because it's a demo, or there's another reason for it?
So the pipeline is also in the Git repository, but this pipeline was getting quite verbose extremely fast. The only reason why this pipeline is still in a single file, it's because it was quite simple. When it gets real, when you start going into production, like, okay, error control, rollbacks, that kind of stuff, then it can get crazy big, crazy fast. Yeah, so then you have to either break or use different techniques. For a simple example, I'm really happy with, like this is already in my maximum amount of complexity that I want in a talk of 45, so. Of course. Thanks. Okay, so I will be around. Thank everyone for coming, and yeah, this is a wrap. Thank you.